By the end of this lesson, the students will be able to deduce the order of reaction using the initial rate method, obtain the rate equation of a reaction from experimental data, calculate the rate constant or the rate from the rate equation, and state the units of the rate constant for zero, first and second order reactions. A and B react according to the equation shown. Click Rate to get the rate equation for this reaction. The rate equation shows how the rate of a reaction is related to the concentration of the reactants. From the above expression, what is the order with respect to A and B? Enter the order in appropriate boxes and click Check Answer. Drag and drop the appropriate expressions into the box to get the overall order of the reaction. Click Rate to get the rate equation for each of the reactions shown. Compare the values of the coefficients in the chemical equation with the powers in the rate expression. Discuss and click Next. Answer: there is no relationship between the coefficients in the chemical equation and the powers in the rate expression. The order of reaction cannot be predicted from the chemical equation. It has to be obtained from experimental data. Enter the value of the overall order of reaction for the given values of M and N. Click Check Answer to see if you are correct. The rate equation for the reaction between A, B and C is as shown. Drag and drop the correct values into the boxes below. The rate equation gives the relationship between the rate and the molar concentrations of reactants in a chemical reaction. The overall order of reaction is defined as the sum of the powers to which the concentration terms are raised in the rate equation. The order of reaction of the reactants can only be obtained from experimental data. Compare experiments 1 and 2. What happens to the initial rate when the concentration of acid is doubled and the other two concentrations remain the same? Answer: when the concentration of H+ is doubled, the initial rate is also doubled. Therefore, the order of reaction with respect to H+ is 1. What is the order with respect to propanone? Click Next to know the answer. Answer: the order with respect to propanone is 1. Comparing experiments 3 and 4, what is the order of reaction with respect to iodine? Answer: the order of reaction with respect to iodine is 0. Even though the concentration of iodine is doubled, the rate remains unchanged. What is the overall rate equation and the overall order for the reaction? Click Next for the answer. Answer: the overall rate equation is as shown. The overall order is 2. The order of the reaction can be determined using the initial rates of the reaction. The order of the reaction with respect to each reactant and the final rate equation can be deduced using the initial rates method. Click Rate to get the general rate equation. Click Rearrange to get the expression for K. Look at the example above. Drag and drop the appropriate values given into the empty boxes to calculate the rate constant. The units of rate constant vary with the overall order of the reaction. To get the unit of K for a zero-order reaction, click Next. The unit of K for a zero-order reaction is as shown. Click Rearrange to get the expression for K for a first-order reaction. Drag and drop the appropriate units to determine the unit of rate constant K. Click Rearrange to get the expression for K for a second-order reaction. Drag and drop the appropriate units to determine the unit of rate constant K. Rate constants can be calculated from the rate equations. The units of rate constants are, for zero order, mole per decimeter cube per second. For first order, per second. For second order, decimeter cube per mole per second. We can calculate the initial rate if the value of the rate constant and the concentrations of the reactants are known. Look at the example above. Drag and drop the appropriate values into the empty boxes. Initial rate can be calculated using the rate equation if the values of the rate constants and the reactant concentrations are known.